Hello, in this video we are going to finish our discussion on section 5.3. We left off finding exact values of expressions involving sine, cosine, and tangent, and I'm going to go ahead and pick up here to make sure that we feel comfortable with these concepts. So we are going to first find the value of inverse sine of 1, which means, since we're finding inverse sine, that I want to know the angle that gives me a sine value of 1. In other words, sine of some angle theta is equal to 1, and I want to know what theta is. Now, inverse sine is only defined on the interval from negative pi, which is to the left around the unit circle, pi over 2 units. So negative pi over 2 around the unit circle to positive pi over 2. So when we're finding our sine of theta equals 1, we're only looking on this right-hand side of the unit circle. And we did that because our function does need to be 1 to 1. So we restricted it so that it is 1 to 1 when we graph it. So I am looking for the angle that gives me a sine value of positive 1. So I'm looking for where does y value equal 1. So around my unit circle, where I start my interval at negative pi over 2, I see a y value of negative 1, which is not what I'm looking for. Here I see a y value of 0, which is not quite what I'm looking for. Here my y values are not 1, but they are equal to 1 at pi over 2. So sine inverse of negative 1 is equal to pi over 2. Now it's not going to be correct to say theta is equal to pi over 2 because there's no theta in our question. They're asking what the inverse sine of 1 is. I only brought theta into it to help us understand what the question is asking. Inverse cosine of pi over 2. So now we are going to look at the interval from 0 around my unit circle to pi. On this interval, we are looking for where the cosine is positive square root of 3 over 2. So we're looking for the x values that have a value of square root 3 over 2. Here I see a negative rad 3 over 2. Here's a positive rad 3 over 2 for x. And no other place do I see a rad 3 over 2. Now, since I'm looking for positive rad 3 over 2, in this interval I am going to be looking at the angle pi over 6 to give me that x value. Now notice that rad 3 over 2 also occurs in a second place on a unit circle, but since we are restricted to the domain of 0 to pi, we are not allowed to continue around our unit circle beyond that pi. I'm going to use the angle pi over 6. So inverse cosine of rad 3 over 2 is equal to pi over 6. And lastly, my tangent function. Tangent, similar to sine, is defined on the interval from negative pi to pi. So I'm looking for a theta value, so tangent of some angle theta is going to equal negative square root of 3. So on the interval, I'm going to look for where could I possibly have a sine over a cosine or a y over an x that's equal to negative square root of 3. Or negative square root 3 over 1. We could also rewrite this as square root of 3 over negative 1. Either of those options would work to give us the negative rad 3. So I'm going to look around my unit circle to where I see square root of 3. And I do want one of the values to be negative and one to be positive. So if I start in the first quadrant, I see that all x values and all y values are positive. So if I take the ratio of a positive number with another positive number, I'm going to get a positive ratio. So that means that I need to be looking in my fourth quadrant. I see two angles that could have a ratio of negative square root 3. So I'm going to test out both of these ratios. My first angle at 11 pi over 6. My y value is negative 1/2, and my x value is positive square root 3 over 2. So if I multiply the numerator and the denominator by 2 to simplify this fraction, I've got negative 1 over the square root of 3, and then rationalizing my denominator by multiplying by the square root of 3, I end up with negative rad 3 over 9, square root of 9, which is 3. So rad 3 over 3. Now that's not what I'm looking for. I'm looking for the negative square root of 3. I'm almost there, but I have a denominator of 3. So I'll look at my other option, which is 5 pi over 3. Finding the tangent of this angle, I've got negative square root of 3 over 2 over my x value of 1/2. So y over x, or sine over cosine. Again, multiplying numerator and denominator by 2, I can reduce these fractions, leaving me with negative square root of 3 over 1, which does simplify to negative square root of 3. That is the tangent value that I'm looking for, so the angle that gives me that tangent value is going to be 5 pi over 3. So inverse tangent of negative rad 3 is 5 pi over 3. Go ahead and take a moment to pause the video and try doing the next few on your own. For the inverse sine of negative 1/2, I'm looking at the interval from negative pi over 2 to pi over 2, where my sine, or my y value, is a negative 1/2. That would be here at the angle 11 pi over 6. Inverse cosine of negative square root 3 over 2, I'm looking at the interval from 0 to pi. The value that gives me an x value of negative square root 3 over 2 is 5 pi over 6. Our tangent is again restricted to the interval negative pi over 2 to positive pi over 2. So I've got options of one positive and one negative x and y value, or two positive x and y values. Since I'm looking for an angle that gives me a positive tangent function, I'm going to be looking for an angle in this first quadrant, where both my x and y are positive. To get a ratio of 1, I need both sine and cosine to be the same, and that would be here at pi over 4, where sine and cosine are both square root 2 over 2. So for example, what I found is that tangent of pi over 4 is the square root of 2 over 2 for my sine over cosine, which is also square root of 2 over 2. Numerator and denominator are the same, so when we simplify this fraction, we get just 1. So the angle I'm looking for is pi over 4. For my sine function, I want the angle that gives me a ratio of positive square root 2 over 2. Again, since this ratio is positive, I'm looking for an angle in that first quadrant where all of my y values are positive. Inverse sine is also defined in the fourth quadrant, but my y values in the fourth quadrant are negative. So I've got a positive square root 2 over 2 at the angle pi over 4, so pi over 4 is the angle I'm looking for. We can use this concept to help us solve trig equations such as the one below. This example is similar to the example you have in your workbook, 533. So I'm going to find one value for x when y equals 4 in this equation, so I replace my y value with 4, and then my goal is to isolate my x. So in order to do that, the first thing I'm going to do is isolate the entire sine function. So I am going to subtract my 1 so that this entire sine function, including its coefficient, is isolated. So I have 3 equals 3 sine of 2x plus 7. Now in order to isolate the sine function, I'm going to divide both sides by 3. Since we are multiplying that entire sine function by 3, I divide by 3 to isolate sine. That then gives me 1 equals sine of 2x plus 7. Now I'm looking for the value of x, or one value of x. So in order to isolate x, I'm going to use inverse sine, which says I have the ratio is 1. What I'm trying to find is the value of x that gives me the angle I'm looking for. So inverse sine of my ratio, which is positive 1, gives me the input, which was 2x plus 7. Now I can find the value of inverse sine of 1 by looking at my unit circle. I'm looking for the angle measure that gives me a y value of 1 on the interval from negative pi over 2 to pi over 2, and that would be here at pi over 2, where my sine, or my y value, is 1. So inverse sine of 1 is pi over 2, because that's the angle on the unit circle at which I get a 1 for y. So pi over 2 equals 2x plus 7, and now I just solve for x by using my properties of equality. I subtract 7 from both sides, pi over 2 minus 7 is equal to 2x. And then I divide everything by 2. In this case, since I already have a fraction on the left, I'll multiply everything by 1/2. 1/2 times 2 gives me just a 1x, or x on the right. Half of pi over 2 is pi over 4, minus half of 7 is 7 over 2. So the value of x that I'm looking for, or one of the possible values of x that I'm looking for, is pi over 4 minus 7 over 2. Go ahead and take a moment to pause the video and practice solving this one on your own. So my first step is to replace the -8 for y. I then isolate the sine function by adding 7 to both sides. My next step in isolating the sine function is to divide by that coefficient of 2, which gives me a -1/2 on the left-hand side. So the ratio that my sine function is equal to is -1/2. The 3x plus 5 is the angle that gets me to that value of -1/2 on the unit circle. So since I have the ratio and I want to know what this angle is, or theta, I'm going to use inverse sine functions. So inverse sine of my ratio is equal to my angle, theta. So now I look on my unit circle for where I have a y value or a sine value of -1/2. Again, we're looking from the interval -pi over 2 up to +pi over 2. So in that interval, I see a sine value of -1/2 at 11 pi over 6. So now that I've identified the angle that gives me that ratio, I can replace my inverse sine function and then solve for x. I subtract 5, I multiply by 1/3 on both sides, and get a final value of 11 pi over 18 minus 5/3 is equal to x. That's one possible solution for the x value. We can take this one step further and use inverse sine and cosine and tangent functions when dealing with composite functions. When dealing with composite functions, we want to make sure we work from the inside out. So here I see the inverse sine of the sine of pi thirds. The inside of this function would be that sine of pi thirds. So I'm going to find the sine value at pi thirds. If I go back to my unit circle, pi thirds occurs here on my unit circle, and the sine value is square root 3 over 2. So then I can replace my sine of pi thirds with the square root of 3 over 2. So this is my sine of pi thirds. Now I want the inverse sine of that ratio. So what I want to know is what angle gets me to the ratio of square root 3 over 2. So again, we can go back to our unit circle. We are looking only on the interval now from -pi over 2 to +pi over 2. So on this interval, I have a sine value of pi square root 3 over 2 occurring at pi over 3. So the angle that gives me a sine value of square root 3 over 2 is pi over 3. So inverse sine of square root 3 over 2 is pi over 3. Now it does work out in this case that my original sine function of pi over 3, when I found the inverse of the sine of that pi over 3, we got back to pi over 3. That was because this original angle was within our domain of -pi over 2 to pi over 2. Looking at cosine, I'm going to find the cosine first of 2 pi over 3, so going back to my unit circle. The cosine of 2 pi over 3 is here on my unit circle, giving me a cosine value of -1/2. So I now have an inverse cosine of -1/2, and I'm looking for the value now, the angle that gives me a ratio of -1/2, but it must be between 0 and pi. Now the original angle that we started with was between 0 and pi on my unit circle, which means that the angle that gets me to that cosine of -1/2 is the angle I started with, which is 2 pi over 3. So the inverse cosine of -1/2 is 2 pi over 3. I'm going to go ahead and end the video here. Please practice the next 4 on your own, and I will start our next section of 5.3 by reviewing this page. Thanks for watching.